My name is Taruneja, and you're watching Brain Security. We are solving the advent of cyber by TryHackMe, and today is day 23. And topic for today is AWS Security Secret Santa. Let us start with the story. One of our stealthiest infiltrated elves managed to hop their way into Sir Carrotbane's office and lo and behold, discovered a bundle of cloud credentials just lying around on his desktop like forgotten carrots. The agent suspects these could be the key to regaining access to TBFC's cloud network. If only the poor hare had the faintest clue that the cloud is he'd burrow in himself. Let's help the elf utilize these credentials to try to regain access to TBFC's cloud network. Learning objectives: learn basics of AWS accounts, enumerate the privilege granted to an account from an attacker's perspective, familiarize yourself with the AWS CLI. AWS accounts can be accessed programmatically by using an access key ID and secret access key. For this room, both of those will be automatically configured for you. The AWS CLI will look for credentials at aws.aws/credentials, where you should see something familiar. .aws means the folder is hidden, most probably. Amazon Security Token Service (STS) allows us to utilize the credentials of a user that we have saved during our AWS CLI configuration. We can use the getCaller identity call to retrieve information about the user we have configured for the AWS CLI. Let's run the following command once the machine loads. Till then, let us go ahead. We go to IAM overview. IAM is nothing but identity and access management. It is just the practice of ensuring that the right person gets right roles and every action is defined already by the admin. Yes, it is just giving right access at the right time to the right person. Amazon Web Service utilizes IAM service to manage users and their access to various resources, including actions that can be performed against those resources. Therefore, it's crucial to ensure the correct access is assigned to each user according to the requirements. Misconfiguring IAM has several high-profile security incidents in the past. If you give sensitive data to someone in very junior role, then it is quite vulnerable, right? Because trust factor is very important. And nowadays, there is this concept of zero trust in which you only provide minimum access, only enough to carry out the particular given task, giving access to resources that they are not supposed to access. Companies like Toyota, Accenture, and Verizon have been victims of such attacks in the past, often exposing customer data or sensitive documents. Below, we have discussed the different aspects of IAM that can lead to sensitive data exposure if misconfigured. Let us run this command first. AWS STS get caller identity. We have user ID, account, and URL, just like it's told in the screenshot. Seeing the output, the elf was overjoyed. Credentials work, and as can be seen by the name, and this belongs to Sir Carrotbane. The elf can now attempt to regain access to TBS's cloud network using these credentials. What is the number shown for account parameter? 1 2 3 4 5 6 7 8 9 0 1. IAM users represent a single entity in the AWS. Each user has credentials such as password and access keys. Normal users having password and access keys that provide them the access to the system. That can be used to access a resource. Further permissions can be granted at user level, defining level of access they might have. IAM groups, group of users. Like for example, if there are 10 board of members, now they are classified into one single group. If there are 100 people in the dev team, they are classified into another group. If there are 50 people in the security team, they are classified in one different group. So why grouping helps? It helps to categorize users as well as the kind of permissions they will need. It helps to better manage your IAM. Multiple users can be combined to a group. This can be done to ease the access of management for multiple users. For example, in an organization employing hundreds of thousands of people, there might be a handful of people who need right access to data, so certain database. Instead of granting access to each user individually, which would be a very cumbersome process. Think of a big MNC like Google. Can it sit and provide access to each and every user? How chaotic that would be. The admin can grant access to a group and add all users who require right access to the group. When no longer needed, they can remove the group. Then we have IAM roles. We saw users, we put them into groups, and now we are going to define the role. Is a temporary identity that can be assumed by user as well as by services or external accounts to get certain permission. Think of the campaign and how, depending on the battle ahead, he might need to assume the role of an attacker or the defender. When becoming an attacker, he will get permission to wield his shiny swords, and when assuming to be role defender, he will instead get permission to carry a shield to better defend kill malware. IAM policies: access provided by any user, group, or role is controlled through IAM policies. There are already certain rules written down that who will have what access. A policy is a JSON document that can define the following: what action is allowed, on which resource, and under which condition, and from whom. Consider the following hypothetical policy where we have SID, effect is allow, principal is Alice, and action is S3 get object. S3 stands for simple storage service. It is used to store objects on AWS, or it is AWS's storage service. Resources are my private. This policy grants access to the AWS user Alice, that is principal, to get an object from an S3 bucket action, or the S3 bucket name my private bucket, that is the resource. Let us ask about S3. Provided by Amazon Web Services, allows you to store data in a scalable and reliable way. Data is stored into buckets, which act as a folder in the cloud where you can store files, applications, backup information, or anything that you need. One IAM component is used to describe the permissions to be assigned to a user or a group policy. Practical enumerating a user's permission. Alright, let's see what we can do with the credentials we got from Sir Carrotbane's office. Since we have already configured them in our environment, we start interacting with the Amazon CLI, the AWS CLI, to find more information. Let's begin by enumerating users. We can do so by running the following command: AWS IAM list users. Got user ID, we got username, we got the path and the created. We will see an output that lists all users as well as some other useful information such as the creation date. Enumerating user policies. Policies can be inline or attached. Inline policies are assigned directly to the user profile and hence will be deleted if the identity is deleted. Direct link is there. These can be considered as hard-coded policies and they are hard-coded in the identity definition. For example, it is already written that, for example, a developer will have all the access to the particular database of the company, but while the tester team, they will only have read access. That is how you implicitly define policies that okay, particular group will have these policies only. That is hard-coded. An attached policy requires only one change in policy, and every identity that policy is attached to will inherit that change automatically. So now in attached policies, what you do, also called managed policies, can be considered reusable. Now you define the policies and you then attach it to a particular identity. So even if the identity is deleted, you can use this particular policy in a different identity that you have created. Let's see what inline policies are assigned to Sir Carrotbane by running the following command: AWS IAM list user policies, username, Sir Carrotbane policy. Great, we can see an inline policy in the result. Let's take a note of its name for later. Maybe Sir Carrotbane has some special policies attached to their account. We can find out by running the following command: AWS IAM list group. Looks like Sir Carbon is not part of any group because we got empty array over here. Let's see what permission this policy grants by running the following command. Replace policy name with the actual policy name you found. Let us just type it out. AWS IAM get user policy. Policy name is Sir Carrotbane policy. Sir error. The following arguments are required. Policy name. We have listed what actions are allowed for this particular policy. List users, list groups, roles, attach user policies, group roles, user policy, group role list, user policies. So it looks like Sir Carrotbane has access to enumerate all different kind of users, groups, roles, and policies, IAM entries, entities. But that is about it. This is not a lot of help getting TBFC access back. We might need to try something different to do that. If you look carefully, you'll notice Sir Carrotbane can perform STS assume role. Maybe there's hope. What is the name of the policy assigned to Sir Carrotbane? Assuming roles, enumerating roles. The STS assume role action we previously found allows Sir Carrotbane to assume roles. Perhaps you can try to see if there's something interesting once available. Let's start by listing existing roles in the account. We will say, oh, okay, yes, now I can see STS assume role. Bucket master action STS assume role. Then okay, yes, we just have one role written over here. There's a role named bucket master and it can be assumed by Sir Carrotbane. Let's find out what policies are assigned to this role. Just as users, roles can have inline policies and attached policies. To check the inline policies, we can run the following command: AWS IAM list role policies, role name bucket master. Policy names bucket master policy. There is one policy assigned to this role. Before checking the policy, let's see if there's any attached policies assigned to the role as well. Attached policies 0. Looks like we only have inline policy assigned. Let's see what permissions we can get from the policy. We have list all my buckets, list bucket, effect is allow, resources allow all, and then we have list bucket, allow these two resources, then get object, allow everything, allow resource this, S3cret, and then everything. We can see that the bucket master role can perform three different action: list all buckets, list bucket, and get object on the same resource of a service named S3. This might be the breakthrough we are looking for. More on the service data. Assuming role. To gain privileges assigned by the bucket master role, we need to assume the role. We can use AWS STS to obtain the temporary credentials that enable us to assume this role. The outward will provide us credentials. We need to assume this role, specifically access key ID, secret access key, and session token. To be able to use this, run the following commands in the terminal, replacing the exact credentials that you received on running the assume role command. Secret access key, session token, everything is being found by assume role, session token. We need these three things. To be able to use this, run the following commands in the terminal. Replace with the exact credentials that you received on running the assume role command. And we export AWS secret access key. We have AWS session token. We have to put it in strings. I hope it won't be an issue. Once you have done that, we can officially use the permission granted by the bucket master role. To check if you have correctly assumed the role, you can once again run this. User ID is this. Account is this. Yes, we did enter this. Bucket master TBFC we are on. Apart from get object and list bucket, what other action can be taken by assuming the bucket master role? Says I will have to run it again. We also had a screenshot over here as well. List get object, list bucket, list all my buckets. Grabbing a file from S3. Before we continue, we need to know what exactly S3 is. It stands for Simple Storage Service. It is an object storage service provided by AWS that can store any type of object such as images, documents, logs, and backup files. Companies often use S3 to store data for various reasons, such as reference images for their website, documents to be shared with clients, or files used by internal services for internal processing. Any object you store in S3 will be put into a bucket. You can think of a bucket as a directory where you can store files but in the cloud. Like that. Now let's see what our newly gained access to Sir Carrotbane's S3 bucket provides us. Listing contains from a bucket. file and let us try it. There is one interesting bucket in there that references Easter. Let's check out the contents of that particular directory or the bucket. Contains cloudpassword.txt. Let's copy the file in the directory to our local machine that might have a secret message. I am encountering this error. If I see this file, if I load these contents and then I exit it using Control C, if I list objects and its contents, whatever thing I list down, after that once I exit it, I am not able to write any command or even paste it. Anyways, let me carry out the process again. You have successfully infiltrated Sir Carrotbane's S3 bucket and exfiltrated some sensitive data. What are the contents of this file? Where is our file? Content type, last modify acceptance. Bucket, Easter secrets, key this, cloud password dot. Sit here, check it. And with that, we are done with the 23rd challenge for the Advent of Cyber. And see you tomorrow for the final challenge.